Water is a highly important component of life, due to the 75% of the Earth's surface that is classified as water and its necessity in maintaining life, as no form of life can exist without water. The movement of water around the Earth sustains a constant supply through the hydrologic cycle, facilitating the storage and movement of water exchanged between the Earth's surface and its atmosphere. The hydrologic cycle consists of a staged system that functions globally, driven from the energy of the sun. Stages of storage and transport within this cycle have been classified with numerous key processes. However, the most significant recognized are evaporation, condensation, precipitation, groundwater, and runoff. Water is constantly moving through the Earth's system with endless cycles, which provide a central role in many physical, chemical, and biological processes. Water vapor is a working fluid which precipitates the movement of the hydrologic cycle through each stage. The stages classifying between transport and storage of the hydrologic cycle are debated in their direct breakup. However, the universal evaporation, condensation, precipitation, groundwater, and runoff are significantly important. The process of evaporation involves the transfer of water vapor from the water surface to the air at temperatures below the boiling point of water. As such, evaporation requires the humidity within the atmosphere to be less than the surface evaporating, lower than the boiling point of water. Significant amounts of latent energy is produced through the evaporation process, as the latent heat involved in the water vapor is released in varying amounts as the water changes in the process of condensation. The change of water to the state of condensation returns water to the Earth's surface, occurring when the temperature falls below a certain degree known as dew point. Although not a constant value, the state condensation results in water droplets are visible in the atmosphere. Water is constant in the atmosphere in these various forms, although not always highly visible. The weather conditions correlate to the water molecules, which combine in particles to form this vital component of the cycle. Condensation causes the formation of clouds, as the atmospheric changes can appear in the form of dew or fog, or can condense to fall as rain or precipitation. The water released from clouds forming from condensation is known as precipitation, which appears in various forms. Rain, sleet, snow, or hail all form connections in the hydrologic cycle as the water returns to the Earth's surface. The form of precipitation depends highly on climate and temperature, although the majority of the global water cycle will fall as rain. It is noted that although the process of condensation is a prerequisite to precipitation, however, not all condensation is cloud formation, is followed immediately by precipitation, as water remains in the atmosphere as some clouds dissipate. Water is seen covering the Earth in lakes, rivers, streams, oceans, rain, and snow. A significant amount of water, however, is unseen, existing beneath the ground. This groundwater is the part of precipitation that infiltrates the cracks in the soil and rocks. Groundwater replaces evaporated water and provides nutrients to plants. Water which is left in excess infiltrates to the water table, the top of the zone which the openings in the soil and rocks are saturated, providing water for streams or springs, and is extracted in wells. Although water infiltrates the ground, excess runoff moves across the surface of the Earth, directed through the elevation of the ground level. Globally, runoff occurs due to an imbalance between the rate of evaporation and precipitation. As such, heavy rainfall may overtax the infiltration capacity of the surface. In the majority of drainage patterns, water will lead inland, evaporating or becoming groundwater. In each case, water will eventually reach an ocean as the hydrologic cycle is completed. The hydrologic cycle provides vital access to water globally, providing the renewable resource throughout the stages of the cycle. As the processes provide groundwater in excess, creating a major source of water for agricultural and industrial purposes, and is an important source of drinking water for many people around the world. Research into the hydrologic cycle provides a significant role in controlling the central heat balance of the Earth's atmosphere. As such, recent research into the correlation between the hydrologic cycle questions it as a key factor in the climate's evolution as the greenhouse gases continue to build up in the atmosphere. As water provides a significant role in maintaining life, the role of the hydrologic cycle ensures access to water globally in an unending, though often interrupted, circulation of the world's water supply.